All right, welcome to the Explainer. Today, we've got something really cool for you. A mysterious substance and what seems like an impossible task. We're going to harness the power of a microscopic creature to do our bidding.
So, let's kick things off with a little mystery. What you're looking at here, it just looks like plain old sand, right? Pretty boring. But here's the challenge. We're going to use this exact stuff to inflate a balloon. And get this, no blowing allowed. Seems impossible, doesn't it? How can a pile of grains possibly do a job like that?
Well, okay, spoiler alert, it is absolutely not sand. What you're actually looking at is a massive, dormant army of millions and millions of tiny single-celled creatures, all just waiting for the signal to wake up and get to work.
So this living sand, it's actually a fungus we all know as yeast. The fancy name is Saccharomyces cerevisiae. And right now, these little guys are basically in a deep sleep, just waiting for two simple things to jolt them back to life: a little bit of warmth and some food.
All right, so let's get to it. Our mission is to prove this yeast is alive in the coolest way possible. We're going to capture its breath. Yeah, you heard me right, and use it to inflate a balloon for us. We're basically turning biology into a tiny little engine.
And you know what's so great about this? It's incredibly simple. You probably have everything you need sitting in your kitchen right now. All it takes is an empty plastic bottle, a packet of that yeast, a couple of spoonfuls of sugar, some warm water, and of course, a balloon. That is the entire list. Okay, the procedure here is super straightforward, almost like a recipe for a magic trick. First, you want to give that balloon a few good puffs to stretch it out. Then, pour about an inch of warm water into the bottle and add your yeast to wake it up. Next, you've got to feed it. That's where the sugar comes in. Then, really quickly, stretch the balloon over the mouth of the bottle to seal it all in. And now for the last step, which is both the easiest and the hardest part. You just wait.
And now we play the waiting game. Over the next, say, 20 minutes to an hour, something pretty incredible starts to happen inside that bottle. It's subtle at first, but trust me, a powerful biological process is kicking into high gear.
So, what are you going to see? Well, first, the mixture will start to get all foamy and bubbly. Then, you might see the balloon kind of twitch and then stand straight up. And then, slowly but surely, it starts to inflate, all by itself. It's alive.
So what in the world is actually happening in that bottle? I mean, we can see the result, but what's the invisible force doing all the work here? What is the yeast actually doing down there to create all that pressure? All right, let's pull back the curtain and get into the science of it all. We're going to see how this simple little mixture turns into a full-blown biological engine. It's time to uncover the secret behind this self-inflating balloon.
Okay, it all boils down to a really fundamental process in biology called cellular respiration. And that's just a fancy way of saying the yeast is eating. See, just like you and me, it needs to break down food to get energy to live. And that sugar we gave it, that's its absolute favorite meal.
And if you want to get technical, this is the chemical reaction that's going on. The yeast takes that sugar, glucose, and through a process called fermentation, it breaks it down. And what comes out the other end? Two main waste products, plus the energy it needs to keep on living.
Now, here's the key. One of those waste products is a gas, specifically carbon dioxide, or CO2. This is literally the exact same gas you breathe out every single second. The yeast is, well, it's breathing out.
So think about it. You have millions and millions of these tiny yeast cells in there, all gobbling up sugar. And every single one of them is releasing a tiny little bubble of CO2 gas. Since we sealed the bottle with the balloon, that gas has nowhere to go but up. It's the combined power of all those tiny little burps that pushes the balloon out and inflates it.
Okay, so watching this happen is really fun, for sure. But to be a real scientist, you've got to start asking, what if? You have to test some variables. This is how we go from just seeing something cool to actually understanding it.
So what could you change? Well, you could play around with temperature. What do you think happens if you use ice-cold water? Or what about boiling water? I'll give you a hint. Yeast is a living thing, and it's kind of picky about its environment. Or you could try different food sources. Will it eat honey or flour? What about salt, or maybe an artificial sweetener that doesn't have any real calories? The results will tell you a ton about what this little organism needs to thrive.
And here's where it gets really amazing. Believe it or not, this simple little experiment in a bottle, it's a miniature version of a process that is absolutely fundamental to human civilization. This isn't just a party trick, folks. It's a cornerstone of how we eat and how we power our world.
That one single chemical reaction, the one happening in our bottle right now, is the foundation for at least two massive, world-changing industries.
First up, bread. You know that light, fluffy texture you love in a good loaf of bread? That's our CO2 gas at work. The bubbles get trapped in the dough, making it rise. And second, fuel. Remember that other waste product, ethanol? Well, that's a type of alcohol. And on an industrial scale, we use this exact same fermentation process to turn crops like corn into biofuel to power our cars.
And all this brings us to a much, much bigger idea. What we've just seen, it isn't just a science experiment. In a very real way, what we've been playing with is technology.
You know, we usually think of technology as microchips and electricity, right? But biology is the original high-tech. With just a little warm water and some sugar, we literally woke up a microscopic workforce and put it to work for us, performing a real mechanical task.
So, what's the big takeaway here? That humble little fungus is one of the oldest and most powerful technologies on the planet, which kind of leaves us with one final big question to chew on. If just a tiny pinch of this dormant life can do all this, what other invisible biological workforces are all around us just waiting for the right conditions to wake up and completely shape our world?